assignment on progressive wave. Equation. So what we were actually given was y is equal to 5 sine of 30 bar times t minus x on 240. Where x and y are in centimeters, where x and y are in centimeters. And t in seconds. Find the I. We are asked to find the displacement when t is equal to 0 and x is equal to 2 centimeters. The displacement when t is equal to 0 and x is equal to 2 centimeters. Then the wavelength velocity frequency. So let's determine this displacement first. So when t is 0, we have 5 sine of 30 pi into bracket 0 minus x is 2. So 2 on 240. Okay. So this is giving us 5 sine of, when we put in this, we have minus 60 pi over 240. Of course, this is 5 sine of 30 pi minus 2 over 240. So when we multiply 2 by 3 pi outside the bracket, we have negative 60 pi on 240. This is the same as 0.06 into 24, I think 4 times. So minus 5 sine of, let me bring it here. 5 sine of minus pi on 4. Since 6 into 24 is equal to this. Okay, and this is equal, the same as minus 5 sine of pi over 4. This is because if you have y is equal to sine of a negative angle, this is the same as negative sine of the angle. And what is pi on 4? Pi on 4 is equal to 45 degrees so minus 5 sine of 45 degrees. And sine 45 is root 2 on 2. So we have y given as negative 5 times root of 2 on 2, which is the same as negative 2.5 times root of 2. And the rest is just calculator work. Please, are we okay? Are we okay with this solution?
Yes, sir.
Okay. Then the next question, find a wavelength. Find a wavelength. Wavelength. So using the same equation, y is equal to 5 sine of 30 pi times t minus x on 240. Please, when I was marking this, I saw a lot of mistakes. The general progressive wave equation is y a sine of omega t minus kx. Then when you expand this by substituting omega 2 pi ft minus 2 pi over lambda x, because of the common 2 pi, then you can decide to factorize out a sine 2 pi out and have within this ft minus x over. Elizabeth, please mute yourself for me. Okay, now you can compare this to this. If the number in front of the sign is 2 pi, they are not the same. They are not the same. Let me flip to the next page. We have y is equal to 5 sine 30 pi times t minus x over 240. Class, I cannot compare this with y is equal to a sine 2 pi ft minus x on lambda. No, why can't I do this? Because these numbers in front of the sign are not the same. They are not the same. The best way I can do this and be able to compare with this is if I am able to manipulate what I'm giving to look like 5 sine of, because I know 15 times 2 pi would give me 30 pi. Then I put the 15 into it. So I have 2 pi times 15t minus 15x on 240. This is the only way I can compare this to this. By this, if I compare straight away, I could see that then F is equal to 15 hertz. Please, are you following what I'm saying? Class, are you following?
Yes, please.
But I cannot compare this to this. This numbers in front. Darius, please mute yourself. Darius. Okay. If I don't want that, the other easier way I can do is that let me multiply the 30 pi through. So I have y is equal to 5 sine of 30 pi t minus 30 bar x over 240. This I can now go ahead and compare it with y is equal to a sine omega t minus kx. Okay, and the value will still be the same. Omega is equal to 30 bar. If omega is 30 bar, then omega, which is equal to 2f is equal to 30 bar again. Bar would cancel out. 2 would go into this, and you will still have f to be equal to 15 hertz. What does the question say? The question asks that we find the wavelength. Okay, so K is equal to 30 bar over 240. Knowing K to be 2 bar over lambda, we can find this and this. Bar will cancel this. So we have 2 on lambda giving us 3 on 24. Okay, and this is 1 on 8. 3 on 24 is 1 on 8. Therefore, lambda will be equal to 2 by 8, which is 16 centimeter. Because we were told that lambda is in centimeter. Velocity, V can be equal to F times lambda. Or this is also the same as lambda over the period. There are a lot of ways to go around this. So how V to be equal to F, which is 15, and then lambda, which is equal to 16. So what is 16 by 15? Lizzie? Leslie, what is 15 by 16?
Please, 240.
240 centimeter per second. Note that the wavelength is in centimeter, so centimeter per second. And what does the last question say? What does the last one say? The last question asks that we find the what? Oh, okay, we found the frequency. So we just code for them that IIF is equal to 15 years. So please, this is the solution to the assignment that was given. And please, this is simple, so it must be done and done well. This is actually not difficult. Okay. Is there any question? Is there any question? Okay, let's look at stationary waves. Stationary waves. Before we look at stationary waves, let me take attendance and then drop it on the platform, okay?
Recording in progress.
Hello, Efia. Efia and Chukonedu.
Yes, please.
Are you following the solution?
Yes, please.
Okay. Okay, so let us continue. All right, so stationary waves. Stationary waves, we've done progressive waves. A progressive wave is termed as a traveling wave. And in progressive wave formation, the medium must be so big. So look at the distinction. In a progressive wave is any wave which can be propagated from one region of a medium, region of the same medium. And in formation of progressive waves, the medium must be so big. What then is stationary wave? A stationary wave. This is stationary or standing. So either you call it as stationary or standing wave. Mamia.
Good morning, Mr. Edia.
Good morning. If it's about 20 minutes to time, draw my attention, okay, for the evaluation.
Yes, please.
So in stationary wave formation, the medium must be so small. So let me sketch a progressive wave, and then we'll give you a stationary wave. So in a progressive wave, if the wave starts from this point, it must be continuously be propagated within the vast medium. So long as the medium is so large, you have a wave whose amplitude decreases with time. So the wave would be dampening. So when the ocean wave starts from wherever it is from, the energy of the wave is transmitted within the particles or water molecules on and on till it dies out at the ocean. Now, with this vast medium, if we decide to create a boundary or build a wall within the ocean, so building a wall within the ocean, we are creating a boundary. What will happen is that the incident wave will start from this point, or when the wind splashes on the surface of the water, it will create the incident wave. And when the wave hits the wall, so we have incident wave. let's use the arrow to indicate incident. When the incident wave hits the wall built within the water medium, it will reflect back and interfere with the incident wave. So we have the incident. This is a reflected wave after hitting the boundary. Please, when you are drawing this, add beauty or aesthetics to your drawing. The marker is not giving me that flexibility to draw well. So you must draw it very well. Okay. So it creates two waves that are interfering or superimposing or superimposing on one another. And this creates what we call stationary wave. Stationary or standing wave. Okay, so in stationary wave formation, the medium must be smaller. And how do we make the medium to be smaller? By creating a boundary or barrier. When you create the boundary or the barrier, the energy of the incident wave hits the boundary and then reflects. When it reflects, they interfere. The incident wave, the reflected wave interfere with one another, creating a stationary wave. Why is it stationary or standing? It is because the energy being propagated only stands between the two boundaries. The energy only stays or stand or is stationary between the two boundaries. That is why we call this as stationary wave. So I want a volunteer to help us based on what you have seen or what you have understood. Share with us your opinion of what a stationary wave is. Any volunteer to do that for us? Share with us what a stationary wave is. Anybody? Anyone to share with us what I said about stationary wave? You may not be exact, but I just want you to share your opinion with us. Erifa, can I hear from you?
Love John, very
Ruby. Okay. Erifa, go about. Continue. In your own view or opinion, what is a stationary wave?
Okay, please, it is any wave which can be propagated from one point of a medium to another that has superimposing waves, and the energy is, let's say, trapped within the medium.
Within the boundary. Thank you. Ruben, can you also share what you think with us? Ruben. Okay, if Reuben is quiet, let's hear from Mamiya. Mamiya, let me hear from you. Mamiya is quiet too. Okay, then I better hear from Mr. Ebia. So, a stationary wave is formed when two waves of equal amplitude. So, a stationary wave is formed when two waves of equal amplitudes. Two, equal wavelength. Three, equal frequency. But traveling from opposite directions, superimpose opposite directions, superimpose or interfere with each other. So when two waves of equal amplitudes, equal wavelengths, and equal frequency but traveling from opposite directions interfere with each other, a stationary wave is formed. Okay. So the moment you reduce the medium from being large to smaller, and then you disturb the medium, you create incident wave. So this is one wave traveling in this direction from left to right. When it hits the boundary, there is another wave whose amplitude. So please, when you are drawing this, ensure that the amplitudes are almost the same. So they have almost the same amplitude. So we have incident wave, then we have reflected wave. So the reflected is from right to left, whereas the incident is from left to right. So clearly, they are traveling from opposite directions. And when they interfere, it creates it. What is the wavelength? The wavelength of the incident, 1, 2, 3. So we have almost 3 complete waves, which is actually the frequency. And the wavelength of the wave is the same, must also be the same. Then it creates a stationary wave. Okay. It creates a stationary wave. Let's look at some applications of stationary wave. Then we look at features of stationary wave. Applications of stationary waves can be seen in most musical instruments such as string instruments, all instruments that uses strings. String instrument, example, the guitar, violin, harp, the cello, etc. Then it is also applied in wind or pipe instruments. Class, give me examples of pipe or wind instruments. Give me a hamamia.
Flute.
The flute. Michelle.
Trumpet.
Come again.
Trumpet.
Trumpets. Trumpets. Elizabeth.
Please, a saxophone.
Saxophone. Yes, another hand is up.
Please, clarinet.
Come again.
Clarinet.
Hey, I can hardly hear you.
Please, clarinet.
Hey, this instrument, then I'm not familiar. Is that trinet?
Please, he said clarinet.
Help me spell it. C-L-A, clarinet. Is that it? Yes, it is. Then the pipe organ. Pipe organ. Trombone. Trombone. Then the harmonica. Harmonica. Okay, so all these are instruments that work on the principle of stationary waves. Stationary waves. So if you look at the string instrument, the guitar, you realize that the strings are tied, the 5-6 strings are tied to 2 boundaries. There's a boundary here, then there's a boundary here. And whoever plays it strikes or plucks the guitar string and then creates an incident wave which goes, hits the boundary and then reflects. So the reflection creates sound of a particular frequency and wavelength. Okay, the trumpet, the air column within the tube must be disturbed by blowing another air within. Okay, the blown air hits the boundary of the pipe or the cylinder and then reflects, creating a stationary wave. So all these instruments works on the principle of stationary wave. It's unfortunate we are ending tomorrow. We would have gone into it and then you have a better understanding of their operation. All right, so please, when you are drawing this, add beauty because the incident and then the reflected waves have the same amplitude, wavelength, and frequency. So add that beauty to your drawing. Let's look at the features of stationary wave. Features of stationary or standing wave. And it is stationary or standing because the energy just is within the limits, this boundary of the limits. So if it's guitar, you see the guitar string just wiggling up and down between the boundary. Okay, so when in stationary waves, energy stays only within the boundary, or the energy transmitted. Energy transmitted is only stationary or localized within the boundary, within the boundary or barrier. Whereas in progressive wave, the energy is continuously propagated within the medium. So that's why I said right from the beginning that in progressive wave, the medium must be so big, large. The medium must be so big or large. But here, the medium must be smaller so that the only energy stays within the boundary. Then, you see, in a progressive wave, it is made up of crests and troughs. This is progressive. When you are drawing waves, add aesthetics to your drawing. Okay, so we have a point where particles are displaced upwardly in that maximum fraction, where particles are displaced maximally in the downward. So a progressive wave is made up of crests and troughs. What about stationary waves? Stationary waves, on the other hand, is made up of, let me draw a quick one and then so we have a boundary here. We have another boundary here. Almost the same amplitude. And the reflected wave something like that. So we have points where particles are at rest. Particles of the medium are at rest. This point where particles are at rest are known as nodes. Nodes. So we have a node here, another node, 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 node. Another node here, and so on and so forth. Nodes are always can be seen at the boundary. Okay, so points where particles are permanently at rest. Known as nodes. N-O-D-E-S, nodes, capital N. Then points where particles are largely displaced. Point where particles are largely displaced, known as antinodes. So points where particles are most displaced, known as antinodes. Antinodes, capital A. So nodes are no motion. No motion. In a layman's language, nodes can be no motion, whereas antinodes can also be most motion. Most motion. So here, no motion of what? Particles. And in most motion of particles. So a stationary wave is made up of nodes and antinodes, whereas a progressive wave is made up of crests and troughs. Elsie, please mute yourself. Elsie. Okay. Now Now, how are nodes and antinodes formed? You see, the node and the antinode is just like what we see in crest and troughs, but a slight difference. How are nodes formed? Nodes, let's talk about antinodes first. Antinodes are formed due to the constructive interference of the two waves. And here, what are the two waves? The incident wave and then the reflected waves. The incident and reflected waves. So when the two waves align themselves constructively in a constructive interference, okay, during constructive interference, the two waves occur at the same angle. And look at something. If this angle, this is 0, this is 180, this is 90. When you look at the reflected, this is also 90, the same angle. So the two particles here are occurring at the same angle. So it's like crest and trough occurring at same angle to form the antinodes. So we say that an antinode is formed due to the constructive interference of the two waves. And in constructive interference occur when two waves traveling in opposite directions are exactly in phase. Please, in phase means that they occur at the same angle. Occur at the same angle. And if the two waves are in phase, and that is similar to what is happening here, the incident wave, which is in blue, the reflected wave, which is in red, both particles or points occur at the same angle, meaning they are in phase. And when particles are in phase, their individual amplitudes add to form a larger amplitude. So when particles are in phase, or particles or waves, their individual amplitudes join to form a larger amplitude. a larger amplitude. So because they are occurring at the same angle, the amplitude of this one, the incident wave, which is from here to here, then the amplitude of this one, which is from here to here, add together to form a larger amplitude. And that is constructive interference of two waves. And that is how antinodes are formed. Then nodes. Nodes, on the other hand, are formed due to the destructive interference of the two waves. Destructive interference of the two waves. Okay. What is destructive interference? Destructive interference also occurs when two waves traveling from opposite directions are out of phase with one another. Please, if you are writing, I'm giving you 2 minutes to quickly do that. But when you finish, just let me know so we can continue. Two minutes to quickly do that. Don't forget to draw my attention when you finish.
Okay.
Can we continue?
Yes, please.
So, destructive interference occurs when two waves traveling from opposite directions are out of phase, with each other. And when waves are out of phase, they occur at different angles. So practically, this is what it means. This is a wave, an incident wave, and then if there is a reflection, this time around, they don't meet at equal angles, but at separate angles. So the amplitude, though they have the same amplitude. Let me just use the up one for this illustration. So imagine, yes, it must be incident and reflected, but for the purpose of this explanation. So if the upper pulse is the amplitude of one of them, the amplitude of another one can be this. Okay, this is 180, this is 270, but they don't meet, meaning they are out of phase. Now, if they are out of phase, then when you refer.
Mr. Edia, please, I don't understand the diagram.
What I'm saying is that I'm using just a progressive way to explain this. Okay, so it must be a stationary wave, but for the purpose of easy understanding, these are two pulses that are out of phase with one another. They occur at different angles. 180, this is another 180 in the opposite side though, but they are same angles, but they are not occurring at the same time. If they are in phase, you see this. This one exactly meeting the other one below. Then they are in phase. Here, this angle and then another angle below. Now, when you subtract these amplitudes, this is A, because it is out of phase, this is minus A. And when you add the two amplitudes, A plus negative A will be equal to 0. So this is what this similar situation is what we call as the two waves being out of phase with one another. So it even means that in progressive wave, the crest is out of phase with the trough. And when two waves are out of phase, they occur at separate angles and their individual amplitudes cancel out and the net result is 0. And that is how nodes are formed. So nodes are formed due to the destructive interference of two waves, where the amplitude of individual waves occur at separate angles and they cancel out each other, and the net resultant is 0. Please, Erefua, are you okay?
Yes, please. But the first diagram, how are we supposed to draw it?
Which first diagram?
That I have cleaned it. The one that like the amplitudes were not the same.
So you are not supposed to draw, but all that you need to understand is that a stationary wave has crest and troughs. And a stationary wave has antinodes and nodes. And in formation of the antinodes, the two waves must align themselves so that their individual amplitudes are in phase and add up to give you a larger amplitude. So that is exactly what is happening here. But in formation of nodes, the two waves align themselves destructively. and their individual amplitude cancel out, and the net resultant is 0. So it is the same thing, but the explanation is what you need. Are you okay?
Yes, please.
All right. Now, you see, when we looked at progressive wave, a wavelength can be decimal. A wavelength can also be from crest to another crest. So a wavelength can also be of this shape. So either this one, or from trough to another trough. So this shape of a wave is a full wave. This is also a full wave. And this is also a full wave. Now, let's apply this to stationary waves. This shape is the shape of a full wave. The wavelength is lambda. The wavelength is lambda. Now look at this shape. We are from node if this shape is a whole full wave and the length of this wave is lambda. In terms of wavelength, what is the length of that? The wavelength of two successive nodes from one node to another node. What is the wavelength? If the wavelength of a full wave is equal to lambda, what will be the wavelength of two successive nodes from node to node, which can be this or this and this? What is, yes, can somebody help? The wavelength of the distance or the length between two successive nodes. Can somebody help? The distance between two successive nodes in terms of wavelength. Jojo, can you help? If this is a full wave, lambda, the length of this wave is lambda, what will be the wavelength of two successive nodes? Okay, for the sake of time, let me address it.
It will be lambda on 2.
So half.
It will be half lambda.
Half lambda. Now, what about the wavelength of a node and then its adjacent antinode. This is a node from here to here. So what is the wavelength?
1/4 lambda.
So this is also quarter lambda. Note that node to antinode or antinode to node, the value is the same. It will also be quarter lambda. Now, what is the wavelength from antinode to the next antinode? From antinode to antinode, what is the wavelength? From antinode to another antinode, what is the wavelength?
Half lambda.
That is also half. Please, if you are not following, this is it. This is one antinode. This is another antinode. We have a node in between. So antinode to node, antinode to node, node to antinode. So we have two. From A to A, we have 2 times node to antinode, which is 1/4 lambda. So the wavelength from antinode, one antinode to another will also be half lambda. This is very, very important in stationary wave. We'll be using this in solving problems. So take note of the wavelength of successive nodes and a node to its adjacent antinode and successive antinode as well. Please, is there any question? If there is any question, quickly ask before we continue. Okay. If there is no question, then let's look at stationary wave equation. We've done progressive wave equation. So let's look at stationary wave. Mami, are you there?
Yes, please.
My timing. So do not forget. Stationary wave equation. So stationary waves are just 2 progressive waves of same amplitude, wavelength, frequency, but traveling from opposite direction. So a progressive wave traveling from left to right has this. Y is equal to A sine, because it's moving from left to right or moving away from the main point. We have omega t minus kx. A progressive wave moving from right to left, on the other hand, that's the reflected. From right to left, on the other hand, has an equation. Y2 is equal to A sine omega t plus kx. Therefore, the equation of the combined wave will be equal to this will be equal to y1 plus y2. Therefore, what is y1? Y1 is a sine omega t minus kx plus y2 a sine omega t plus kx. And when we factorize out a, we have sine omega t minus kx plus sine omega t plus kx Can you simplify what is in the bracket for me? Class, can you do that? And I want you to take it one after the other. Simplify sine omega t minus kx and simplify sine omega t plus kx. When you finish, you then add them together. You are doing this using this formula, sine a plus b must be equal to sine of a times cos of b plus cos of a times sine of b. And sine a minus b is also equal to sine of a times cos of b minus cos of a times sine of b. This is what you are using to simplify this. So it means that here a is equal to omega t and b is equal to kx. Plus, I'm giving you 5 minutes to simplify what is within the square brackets, after which I'll get back to you. Is that okay? Class, is that okay?
Yes, please.
All right. Just make me proud. We'll discuss it after the 5 minutes. Are we through? So let's look at it. So we have y is equal to a out sine omega t minus kx plus sine omega t plus kx. If we simplify what is the first part would give us sine omega t cos kx minus cos omega t sine kx. Then simplification of this part will be sine omega t cos kx plus cos omega t sine kx. Then we'll realize that cos omega t sine kx being negative plus this and this would cancel out. So we have y is equal to a into brackets. This is 2 sine omega t cos of kx, which is 2a cos kx sine omega t. This is the stationary wave equation for a rigid barrier or boundary. A rigid boundary. Now for open boundary, the equation of this is equal to 2a sine kx cos of omega t. Or the stationary wave equations can be this or this one. This is for open boundary, and this is for rigid boundary. So in strengths or stationary wave formed, okay, as a result of having barrier or boundary at both ends, this becomes the equation. And the stationary wave formed as a result of having open boundary, such as in wind instrument, trumpets, saxophone. The second one becomes the equation of the stationary wave. Please, is there any question? Is there any question with the special stationary wave equations? Okay, I'm sending a question to the group. I've just forwarded a question to the group. There are two waves traveling in opposite directions. Two waves traveling in opposite directions produce a stationary wave or a standing wave. Produce a standing wave The individual wave functions y is equal to a sine to bracket kx minus omega t r. So we are told the individual waves are y1 4.0. Do not write the centimeter. Sine of 3.0x minus 2.0t. Then y2 is also 4.0 sine 3.0x plus 2.0t. I'm modifying the question there. Write the equation of the, or derive the equation of the stationary wave. Derive the equation of the stationary wave and 2, determine the displacement of the stationary wave when x is equal to 2.3. Determine the amplitude of the stationary wave at x is equal to 2.3 centimeter. Okay, so time isn't on our side, so let's quickly do it together. So we have y is equal to y1, this is 4.0 sine of 3x minus 2t, and y2 4.0 sine of 3x plus 2t. So over here, this is A, this is B. This is A, this is B. So if we expand sine, so y equation of the stationary wave must be this. Therefore, for out, we have sine of 3x minus 2t plus sine of 3x plus 2t. So in effect, y will just be equal to 4 times sine 3x cos 2t minus cos of 3x sine of 2t plus sine 3x cos 2t plus cos of 3x sine of 2t, and this will cancel out. So we'll have 4 times 2 sine of 3x cos of 2t. Therefore, the equation of the stationary wave will be equal to 8 sine 3x cos of 2t. Please, class, are we okay? Are we okay with this?
Yes, please.
So this becomes the equation of the stationary wave. Now, what is the amplitude when x is equal to 2.3? You see, when you compare this to the equation of the stationary wave to the equation of a progressive wave. A progressive wave, we simply have A sine omega t minus kx. Or even if it's sine, if it's cosine, okay, this is the amplitude. A is the amplitude. Over here, the amplitude is in itself a whole trigonometric function. The coefficient to the 2t becomes, or the time becomes the amplitude. So the amplitude of the stationary wave is 8 sine 3x. It's in itself a trig function. So you pick the amplitude of the stationary wave, which is a trig function, and then substitute when x is equal to 2.3, what will be the amplitude? So we are going to substitute 2.3 for x. So 8 sine 3 times 2.3. This is equal to 8 sine of, we have 6.9. 6.9 in radians. So change your calculator's angular measurement to radians and then input this. Or change 6.9 to degree. It's easier changing it to radians. So let's change the calculator's angular measurement to radians. And then input sine of 6.9. What are you making for sine of 6.9, class? Yes, what is the sine of 6.9? Anyone?
Please, I had 0.5
7, 8.
784.
Good. So we have 8 times 0.5784. Then multiply 8 by this.
4.6275.
4.628. 4.628 centimeter. This is the amplitude of the stationary wave when x is equal to 2.3. Elizabeth.
Mr. Lydia, please, after you changing your calculator to like the radian function, when you are multiplying with like the 8, should you change it back to degree, or you can still multiply it like?
No, 8, the coefficient to the sine. So we have 8 sine of 6.9. This is just a number. This is just a number. So it's like 8 times sine. It is just the angle. The angle is the number in front of the sine or cosine.
Okay.
That is what we are changing. But the 8 is just a number multiplying it.
Okay.
A very good question. So please note that. So that is why if we have pi sine of 2 pi over here, because the number in front of the sine is an angle, that is why we could change even power to 180, multiply by 2, and then get power times sine of 360. But we cannot say that this power is also 180. Please, are you following?
Yes, please.
We can only use 22/7 or 3.142 for that power, but we can't say that that is also 180 because this coefficient to the trig function is a number. But when it appears, okay, in front of either sine or cosine, it's an angle theta. All right.
Yes, please. Thank you.
Okay. So this is the beginning of stationary waves. And when you understand it, and honestly, solving questions is very, very interesting. Okay. Mamea, Efia, Eva, are we there?
Yes, please. Please, the 20 minutes to time has reached.
Okay. Okay, class. So let's use this section to go through the teacher evaluation. I've just forwarded the form, okay, on the page. Let's all tap on the link and open it. I'm doing same, so I'm expecting each one of you to also do same for me. So let's open it. Tap on the link to open. Please, is it opened?
Yes, sir.
All right. So Omega teacher evaluation form. Evaluation form on your physics teacher. Okay. Dear students, management of Omega Education Consult wishes to seek feedback from you to strengthen the quality of teaching and learning. The purpose is to improve teachers' performance in online engagement with students to bring excellent appreciation of topics taught. Please be assured that all responses will be kept completely confidential. We have done this before, though some of you are new here, but we have done this before. So item 1, links to joining the class are shared before the scheduled start time. A, never shared before time. B, sometimes shared late. C, often shared late. And D, always shared before the time. So pick the one that is suitably applicable to the Sabia. Just choose the one you think. Number item 2. Does the teacher skip classes? A, skips class most of the time. B, skips class sometimes. C, never skips class. Over to you. 3, give the number of times the teacher has skipped classes. And then A, we have 0, 1, A, B, C, up to E. We have 0, 1, 2, 3, 4, and above. So pick or choose the one that you think is applicable to me. 4, teacher makes alternative arrangement if he or she is unable to attend class. A, never makes any alternative arrangement. B, sometimes makes alternative arrangement. C, has never skipped class. I hope you are picking the right alt. 5. Teacher is willing to answer your questions privately after lessons. A. Never answers any questions privately. B. Ignores my private questions. C. Sometimes answers my private questions. And D. Always answers my private question. Item 6. Are reasons given for not answering your questions privately? A. No. A. No. A. No. No reasons given. B. Sometimes reasons are given. C. Yes, reasons are always given. And D. Not applicable. 7. Teacher's voice is very clear during class session. A. Voice is always low. B. Voice is sometimes clear, other times not clear. C. Voice is most of the time clear. And D. Voice is clear at all times throughout the lesson. Item 8. How clear are writings and illustrations on board and screen? A. Handwriting is not clear. It is difficult to read. B. Handwriting is sometimes not clear. C. Handwriting is clear at all times. And item number 9. Background of the teacher during lessons is A. Always noisy and disruptive. B. Sometimes noisy. C. Always quiet throughout the lesson. Then 10. The teacher gives assignment on topics taught. A. Never gives assignment. B. Occasionally gives assignment. C. Often gives assignment. And D. Always gives assignment. 11. Teacher marks assignment promptly and gives feedback for improvement. A. Never marks assignment given. B. Occasionally marks assignments given. C. Marks some and leaves others. And D. Always marks and gives feedback for improvement. 12. How many exercises, tests, assignment, homeworks, or group works, etc. have been given by a teacher? So pick A, B, C, D, up to F. 13. My level of understanding of what is taught is A. I do not understand most of the time. B. I understand some of the concepts. C. I understand most of the concepts. And D. I have excellent understanding of all concepts. 14. Are videos of lessons shared with you? A. Never. Never shares videos on lessons. B. Sometimes shares videos. C. Shares videos on all lessons. Then 15. Rate the stability of teachers' internet connectivity. Rate the stability of teachers' internet connectivity. A. Connectivity is always bad. B. Network drops frequently. Network drops frequently. C. Network drops occasionally. And D. Network is consistently stable throughout the lesson. 16. The method used in the lesson delivery is A. Less interactive. quite interactive. C, very interactive. And D, excellently interactive. Then, somebody say, would you like to maintain your teacher? No, I wish to have a different teacher. B, maybe. C, yes, I will always like him or her to teach me. I think in ours, we should always also be asked if I want to maintain my students. 18. I will join Omega vacation classes in my next vacation holidays. A, no, I will not join Omega. Omega. B, I'm not sure if I will join Omega. C, yes, I will definitely join Omega. 19. Did the teacher meet your expectations? A, no, my expectations were not met at all. Yes, my expectations. B, my expectations were somehow met. C, yes, my expectations were met to a large extent. And D, yes, my expectations were excellently met. 20, any other comments about the teacher? Over to you. 21, any other comment for Omega management? Over to you. So I'm giving you about 3 minutes to input 20 and 21. 3 minutes. If you want to, any comments about the teacher and any comment for Omega management? Just 3 minutes to quickly do that. After inputting comment about the teacher, comment about Omega or for Omega management, please tap on submit. If you don't do that, all that you have done from start is wasted. So after answering question 20 and 21, kindly tap on submit. Tap on submit. Very, very, very important to end the show. Please, tomorrow we'll be solving questions, especially on weights. Okay, because when we started, I did not give you math questions to probe your conceptual understanding. I'll be doing that tomorrow. Then other areas as well. Don't forget, we've done 3 topics: circular motion, simple harmonic motion, and wave motion. So tomorrow will be reserved for questions solving and then, answering your personal questions to just draw the curtain properly on the whole 2 months of engagement. Have we all submitted? Class, have we all submitted?
Yes, sir.
Let me hear from the rest of you as well. Have we all submitted?
Yes, please. Yes, please.
All right.
Yes, please.
Okay. Then this is where we draw the curtains on today's show. Thanks for your time, your contributions, your support in the teacher evaluation and everything. We'll continue same time. I think, is it same time? No, at 3 to 5 tomorrow. May the good Lord be with you, guide you, and bye-bye. Okay. All right.